Hello students, and welcome again to another video. Today we're going to be discussing the activity series, okay? Before you watch this video, please watch the video before this on single replacement reactions, because this is the second part to that. It's going to be explaining what is the element that's replacing the other element in a compound. Why is it happening, and why is it not happening in certain circumstances? So the activity series lists the relative reactivities of elements within groups, such as metals and halogens. So in class, I've got this table for you, okay? It's laminated, you see how it's kind of shiny, okay? It's gray, and it's in the folder up in the, the front of the class, and you can go grab one of these when you're working on these problems, okay? And you can use this on your test as well. You do not have to memorize this, okay? If we look, we have this activity series of metals and halogens. Now think about, why would I separate the metals from the halogens? Okay, the metals are givers. Lithium wants to give electrons, potassium wants to give electrons, while fluorine, chlorine, bromine, and the rest want to accept electrons. We have the takers and the givers, so we have to specify what type of reaction is happening. Is it an element that's taking or giving? Okay. All right, now that same list is right here in your book, so in case you need it, it's right here, okay? Now let's scroll down here and let's see if we can get to this problems down here. Okay, we have two problems that we're gonna look at. We're gonna look at zinc and lead nitrate reacting to form zinc nitrate and lead solid. Now, zinc is going to replace lead. Now, why is zinc going to replace lead? Well, it's because it's higher on the activity series. Because we have a lead nitrate solution, okay, it's happily an aqueous solution. The nitrate and the lead are just separated from each other. But once I add zinc, solid zinc to the solution, it's going to replace the lead. And the lead's going to fall out of solution and be solid again, okay? So let's look at this. Zinc on this table is more reactive than lead is. It's higher up on the list because this list shows increasing reactivity. So zinc is going to replace lead because it's more reactive. Okay, so that's going to happen. There's going to be a reaction that occurs. Down below, we have copper solid. We have a solid copper wire. You can just imagine putting copper wire in an iron sulfate solution. So iron sulfate, it's dissolved, nothing's happening until I put copper in. Does the reaction occur? Well, it doesn't occur, because iron is more reactive than copper. So if I look at my list, iron is higher on the list than copper is. So keep that in mind. You have to look at this to predict what's going to happen. So if I didn't show you the second half of these equations, you'd have to make a prediction. Well, all you got to do is just look at this table. It's pretty straightforward, pretty simple, okay? Now, let's keep in mind, metals from lithium to sodium will replace hydrogen from acids and waters. Okay, you see how this has a little asterisk sign here? Okay, so if we're looking from lithium to sodium, it's these are very reactive. They will strip that hydrogen off of water molecules and acids. While from magnesium to lead, so this section from magnesium to lead, which is right above hydrogen, will only replace H's and acids, okay? And we haven't really talked a lot about acids. We'll probably talk about that near the end of the year. But keep in mind, if we put magnesium, for example, we did that experiment on the single replacement reaction where I put sodium and water and it reacted. Magnesium, do you think it's going to react? Well, let me write it out. Let's do this. Let's practice. Come up with a problem on the fly. So we've got magnesium solid plus H2O, and that's a liquid, okay? Will the reaction occur? And based on this asterisk, metals from lithium to sodium will replace hydrogens from acids and water. Ooh, see how there's water there? Now, magnesium, is it in this range of lithium to sodium? It is not. It's below that. Magnesium will only react with acids because acids have an extra H on there and they want to donate that. So let's look here. So this is not going to happen. This reaction will not occur. But if it's any of the elements from sodium to lithium, sure, it's going to react. Even calcium will react with water, okay? May not react as violently as some of the other ones on that list, but it will still react, okay? All right, thanks for watching.